Hello class, welcome to today's lesson. Today we're going to conclude the topic, the lesson 3.1, okay, which was about distance between 2 points, area, volume, and angles. And you're going to notice that I'm not going to talk about area and volume yet, even though I wrote this at the beginning. And actually we have these two topics in this lesson 1. I'm gonna relay these two concepts, area and volume, and we're gonna look at these two things in fifth semester. Okay, so it's gonna take a long time for us to see these two concepts, and there is a reason. There is a reason for this. Okay, I'm not doing it haphazardly. There is a reason for this that you will understand in fifth semester when we look at calculus. So just wait for these two concepts to be studied. Of course, I'm not gonna grade you in these two areas in this semester, so you should not worry about that. And you should not worry about this fact of me relaying these two things until the end, because the order in which we see the topics is not really that important. So today we're gonna finish this lesson by solving these two problems. We're gonna find the distance between two parallel lines, and we're gonna find the angle between two intersecting lines. So let's go over the first problem. So for example, if I have here my usual Cartesian plane, and I have two parallel lines, like in such way maybe, okay? I'm gonna call this one L1, line 1, and line 2. Okay, so I want to calculate the distance between these two parallel lines, okay? And what do we mean by that? We mean exactly the distance. For example, if you locate one of the points in L1, well, basically, what we understand by the distance between two parallel lines is the distance going from this point to another point in the line 2, such that the segment joining them, this segment, is perpendicular to both lines. Okay, perpendicular to both lines. So basically it is the length of the perpendicular segment going from L1 to L2. Okay, so don't make the mistake of thinking that you can actually, for example, I don't know, if you calculate distance from here to here, even though that is a distance between these 2 points, that is not what we understand as a distance between L1 and L2. It has to be done as a perpendicular segment. It is this little bit. This is the distance. Well, this is the length of the segment that joins L1 and L2. And this is what we understand by the distance between L1 and L2. So we want to calculate that distance. And be aware also of another fact. This concept of the distance between two lines is only defined for parallel lines, only parallel lines. Because if we have two intersecting lines, like so, okay, there is no such distance. We cannot define really a concept as distance between these two lines, because what distance am I talking about? Like this one, or this one, or which one, right? Each of these distances between these two lines are different, and they're gonna be ever more different as I go far away in this direction, right? So the concept of distance between lines is not defined for intersecting lines, only for parallel lines. So let's see how it's done. It's a very simple thing. Okay, let me erase all of this. And suppose that I want to find the distance between these two lines, L1, which is given by this equation, and L2, which is given by this other equation. So this is the example I'm going to solve for you. So I need to find the distance between these two lines. What is the first thing I got to make sure of? I got to make sure that they are parallel. Are these two lines parallel? Well, let's check. All I need to do is put them into the parallel intercept point form of the equation. For example, this first equation, which is L1, if I put it in this way, then I divide over 2, we get this. Okay, this is L1, and we can see right away that is a slope is 2, right? And if we do the same for L2, which I'm gonna do over here, we have minus 4x plus 2y minus 2 equals 0. And I do the same thing. I'm gonna put it in slope intercept form. So here we go. There you go. We divide both sides over 2, and we get 2x plus 1. So this is L2. And what is the slope of L2? Is 2, and the intercept is 1. And here the intercept was 2. Okay, so in fact, we can see that the slopes of both lines is 2, and that means that both lines are parallel, right? Because they have the same slope. If I actually wanted to graph both of them, I'm gonna just briefly sketch these two lines, L1 and L2. They're gonna look more or less like so. 1, 2, 1, 2, 3, 1, 2, 3, 1, 2. Okay, this one, for x equals 0, we have an intercept of 2, so this one goes over here. This is going to be L1, more or less. And L2 is going to look more or less in this way. It's going to cross right over here. Okay, more or less. Okay, so this is what you do. You first make sure that they are parallel, because remember that this concept of distance between two parallel lines is only defined for parallel lines, not any other type of line. Okay, so they are parallel and we can continue. What else do we have to do? The next thing you have to do is this. You're gonna locate any point in any of these two lines. For example, take L1 and locate one point that belongs to such line. For example, this intercept. Okay, this intercept right here. What is their intercept? That intercept is the point 0, 2. So this point 0, 2 belongs to L1. Make sure of that. It's very simple to see. All you have to do is give x the value of 0, and you're going to get the value of 2 for y. There you go. Okay, now, next, what do we do? What we do is we're going to find, let me erase this point over here. We don't need it anymore. What we're going to do is find the equation of the perpendicular line going through that point, and which is perpendicular to L1, like so. This one. Okay, I'm gonna call this one L perpendicular. Okay, you can call it whatever you want. L perpendicular. Okay, and remember, this perpendicular line is perpendicular to L1 and therefore is perpendicular to L2 also, right? And L perpendicular is going through this point. Let's call it point P1. And remember, point 1 was, in my case, I decided that it was going to be 0, 2. You can go for any other point. It doesn't matter. It doesn't matter what point you choose. So you have this point 1, and the next thing I want to find is the equation of L perpendicular. Okay, L perpendicular. What's going to be the equation of this thing? How do we find this equation? What's going to be the equation of this thing? What's it going to look like? Okay, so first, let's see. If we know that this line is perpendicular to both L1 and L2, that means that it's that its slope, which I can put like this, has the property that when you multiply it with either of these slopes, okay, what's going to be the result? The result has to be minus 1. I hope you remember that fact. When you have two perpendicular lines, okay, L1 and L2, and L1 has slope of M1 and L2 has slope of M2, if they are perpendicular, we know that the multiplication of their slopes, M1 times M2, has to be equal to minus 1. So the same has to work in here. If the slope of this L1 is 2, then when I multiply that 2 times this other slope, the result has to be minus 1. So let's actually find that slope. All I need to do is isolate and then substitute what the M was, which is 2. There you go. So this is the slope of the L perpendicular. Okay, so we already have the slope. What else do we know about L perpendicular? We know one of the points through which it goes, which is point 1. So basically, L perpendicular has this slope and it passes through this point, 0, 2. Is that enough information to come up with its equation? Of course, because we know, if you remember, let me erase this thing. We know that if we know the slope of a line and one of its points, then we can use the point slope form. Point slope form of the equation, right? Which was like so. Remember? There you go. In which m is the slope and x1, y1 is the point. So all I have to do is to substitute these two things, okay? This thing and this thing in here, in this form. So y minus y1, which is 2, equals the slope, which is minus 1/2, times x minus x1, which is 0. There you go. And we just try to simplify. There you go. And there you go. This is my equation for L perpendicular. This one right there. Y equals 1/2 times x plus 2. There you go. Now, why did I want to find this equation for this perpendicular? Because next what I have to do is this. Remember, what we need, guys, is the let me locate this point over here. All I need to do next is locate at which point this blue line, the perpendicular line, at what point it crosses L2. This one, okay? Because if I can find this point somehow, okay, which I can call point 2, okay, for having some consistency. Point 1 is on line 1 and point 2 will be on line 2. Because if I can find this point, then all I need to do now is get the distance between point 1 and point 2, okay, because this would be the distance of the perpendicular segment that goes from L1 to L2. Okay, so I need to find this little point right here, point 2. And how do we find that point? Okay, what you need to do is, you know the equation of L2, which is this one. This is the equation of L2. Do you know the equation of L perpendicular? Yes, it's right here. This is the equation of L perpendicular. Okay, and all that remains to be done, guys, is solving this system of two equations, which I can separate. Let me erase this thing here. It's just a simple system of two equations with two variables. We solve it, and we are completely done. We by solving it, we can find that point 2. So you need to solve this system. Y equals 2x plus 1 and y equals 1/2 times x plus 2. Very simple system of equations. Okay, you can see right away that if y is equal to this and y is equal to this, then 2x plus 1 is equal to 1 half times x plus 2. And we can solve this equation for x, which is going to be this one. There you go. Okay, I'm doing these things very quickly. Okay, you can make sure in a moment. Am I doing everything correctly? Yes. So x equals 2/3. And how do I find y? By just inputting this thing in either this equation or this equation. When you do it, you will get 4/3 plus 1, 7/3. Yes, make sure, please. I mean, if you put this here, 4/3 plus third, yeah, that's right. So this is the point P2, guys. This is the point P2. This point right here, this point right there, P2, is the point whose coordinates are 2/3 and 7/3. There you go. So basically, we have all the information. And point one, by the way, was 0, 2. And we have all the information in order to calculate the distance between point 1 and point 2 because we have the coordinates, right? And by finding that distance, I would be finding the distance between L1 and L2. So that's how it works. Okay, I'm not gonna do that thing. So let me summarize very briefly what you have to do again. So you are given two lines, okay, line 1 and line 2. First, make sure that they are parallel. If they are not parallel, you cannot calculate the distance between them. And then, what you have to do is locate one of the points over L1. Which point? It doesn't make any difference. Label it as point 1. Then, find the equation of the perpendicular to L1 that goes through point 1. And you can call it whatever you want. You can call it L3, L perpendicular, L whatever. Okay, so now let's suppose that you already have the equation of L3, this perpendicular line. So since it is perpendicular to L1 and L1 is parallel to L2, then that means that L3 will also cut L2 perpendicularly at this point, at point 2. Okay, then find this point 2 by solving that system of equations between L3 and L2, and finally just find the distance between these 2 points like I did, and that will be the distance between L1 and L2, and you're done. Okay, now the next problem, problem number 2. How do we find the angle, the angle between two intersecting lines? Let's see what this means. Okay, for example, one more time, if I draw the Cartesian plane and I'm gonna draw two intersecting lines like so, let's label them L1 and L2. We can see that when two lines cross one another, they form two pairs of different angles. Okay, this one, which is the same as this because they are angles opposite by the vertex. I hope you remember that from elementary geometry from junior high. So this angle is equal to this angle, but they also form this other couple of angles, this one and this one, which are also the same. So when I talk about, let me erase a couple of them right there. So when I talk about two lines intersecting one another, they form two different angles, this one and this one. Let me call this one angle 1 and angle 2. And so basically, when we talk about the angle between two lines, we are referring to the smallest angle, always the smallest angle. One more time, when I talk about the angle between two intersecting lines, I'm always talking about the smallest angle. And that's the angle that we want to get, this smallest angle. Okay, in order to find that, let me put you in a little bit of context. First, let's remember the definition of of the trigonometric functions of a right triangle. If we have a right triangle, then let's label this angle as alpha, and let's label this cathetus as A, this one as B, and the hypotenuse as C. And there are three trigonometric functions that we're going to study in more detail later. Okay, sine of alpha is defined as opposite cathetus over the hypotenuse. Cosine of alpha is defined as its adjacent cathetus, adjacent to alpha, I mean, over the hypotenuse. And the tangent of alpha is given by opposite cathetus over adjacent cathetus. There you go. So these are the definitions of the three most important trigonometric functions. Okay, and also let me tell you how to get the angle of a single line. For example, if I draw this line over here, let's call it L1. Let me tell you how to find the angle of L1, the angle that it makes with the positive x-axis, which is this angle right there. Okay, I'm gonna call it angle 1, this angle. Okay, how do we find this angle? We do the following. I'm gonna locate this point over here. I'm gonna call it point 1, and I'm gonna locate any other point that lives on L1. And I'm gonna call it point 2. Okay, so I know these 2 points. I know point 1 and I know point 2. Let me write their coordinates too. That's a good idea. Point 1 has coordinates x1, y1. Point 2 has coordinates x2, y2. Okay, and basically, what can we do? We can do the following. Look, I'm gonna drop a perpendicular from this point to the x-axis. There you go. And if you notice, this is, I don't know if you remember these words. This is what we know as the rise, and this is what we know as the run. Okay, and these are the two segments of lines. This segment and this segment. They are the segments that define what the slope means. Okay, remember that the slope of a straight line, the slope m, is defined as rise over run when you go from point 1 to point 2. Okay, when you go from point 1 to point 2, you take a run of this much, this segment up until this point, and you rose all of this. Okay, so the ratio between the rise and the run is what is known as the slope. And remember that we can actually calculate that when we have the coordinates as y2 minus y1 over x2 minus x1. We know this already. Now, how does this help me in the in the in getting this angle 1 of this line L1? Well, it's very simple. If you notice by looking at these things, guys, what we're doing is this. Look, I can write the following. I can write tangent of angle 1 is equal to, according to my definition of tangent, the tangent of an angle is equal to its opposite side, as you can see, over its I'm sorry, no, I made a mistake right here. So sorry. This is B. The tangent of an angle is its opposite side over its adjacent side. There you go. I made a mistake. I'm so sorry. And we can employ this definition over here. The tangent of this angle, the tangent of angle 1, will be equal to this bit, which is known as rise, over this bit, okay, this cathetus, which is known as the run. So you see, it's basically the same definition as the slope, you see? So tangent of angle 1 is equal to y2 minus y1 over x2 minus x1. and I can see that they are the same definition. Tangent of the angle 1 is the same as the slope of this line L1. And so I can write this. Tangent of angle 1 is equal to the slope of this line. And basically, if I want to know the angle, all I need to do is isolate by applying the inverse tangent of the slope. And I suppose that by now you know how to perform this in the calculator. Okay, even if you don't understand very well what's happening here, like inverse tangent, just do it, okay, in the moment, for the moment. You will understand what that means a little later in this stage, in this topic. So that's how you get the angle of a line, okay, the angle that it makes with the positive x-axis. All you need to do is take the inverse tangent of the slope. That's all we have to do. Okay, now write this down, please, somewhere, and let's see how that can help me solve the problem. Remember, what we need to do is, if I'm given two lines that intersect one another, for example, line 1 and line 2, I want to find the smallest angle that they make, which is this one, right? It's this angle. I want to find this angle. I'm going to call it, let's call it angle 1. Let me put it with a number. Angle 1, which is the same as this, okay, because they are opposed by the vertex. Well, no, it's not a good idea to call it that. Let me tell you why in a moment. Let's call it something different. Look, I'm gonna call angle 1, okay, the angle of L1, the angle that it makes with the positive x-axis. Okay, so I'm not gonna name this angle 1 for that reason, and I'm gonna call this angle 2, which is the angle that L2 makes with the positive x-axis. And the angle that these two lines, L1 and L2, make between themselves, which is this one, let's call it theta. Okay, so this is theta. Both of these angles are theta. Okay, and I can call this other angle over here, let's give it the name 3, angle 3. So we have angle 1, angle 2, angle 3, and theta. And I'm looking for theta. I want to calculate this angle. What do? We can do this, guys. We can get this angle by knowing the angle 1 and the angle 2 of these two lines. Okay, why? Because of the following. I want you to look at this triangle right here, this one that I'm tracing, okay, and you can see that its internal angles are angle 1, which is this, plus angle 3, which is this, plus theta. And a very well-known fact about triangles is that the sum of their internal angles is 180, right? So this plus this is 180. Let me call this equation 1. Now, also, the geometry of these two angles, angle 2 plus angle 3, clearly tell me that those two angles, the addition of those two angles, angle 2 and angle 3, has to be equal to 180 degrees too, okay, because they complete half a turn. The sum of these two angles completes half a turn. Okay, let me call this equation 2. And now we can do the following. If this is equal to 180 and this is equal to 180, then this and this are equal to themselves, which I can put in this way. There you go. And angle 3 belongs in both sides of the equation, so I can cancel it. And this leaves me the following. Angle 1 plus theta equals angle 2. And basically theta would be equal to angle 2 minus angle 1. So basically, how can I get theta? Well, I can get it by getting angle 2 and angle 1. What is angle 2? It is the angle that the line 2 makes with the positive x-axis, and angle 1 is this angle, which is the angle that the line 1 makes with the positive x-axis. But I told you just a minute ago, okay, that if you have any line, I'm gonna do it here again, any line 1, angle 1, you can get its angle by this formula. The tangent of the angle is equal to its to the slope of the line, and the angle 1 is gonna be equal to the inverse tangent of the slope. Okay, so basically get the slope of this line, get the slope, then calculate its inverse tangent, and that would give you this angle. It's that simple. So basically what you have to do here is get the slope of L1. Okay, let's suppose that you already have it. Get the slope of the line 2, which is M2, and then with these two slopes you can get the angle 2 and the angle 1. The angle 2 will be equal to the inverse tangent of M2, and the angle 1 will be equal to the inverse tangent of M1. And that's it, guys. Now all we need to do is go like this. Theta is equal to inverse tangent of M2 minus inverse tangent of M1. That's how you find it. That's how you can find the angle between two lines that intersect one another. And remember, we always talk about the smallest angle. So that's it, guys. You're gonna put this into practice in a moment.